get into the big topic of open source, something that we actually say at Red Hat.
We have a
This is so awesome.
are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say
As the Kubernetes ecosystem really boomed,
Hello, good morning, good evening, good afternoon, wherever you are in the world. I am Jonny Rickard, and I am I'm now the host and co-host of the Ask an OpenShift Expert live stream for today anyways. I've got James Harmison with me today. James, you want to do a quick intro?
Yeah, hi, James Harmison. I'm a senior principal technical marketing manager, which is a lot of words. That means I'm a nerd that tries to talk about our stuff with people who aren't necessarily yet customers, but are interested in it. I've been at Red Hat for about 6 years now, working on a lot of stuff, including as an OpenShift SSA with Jonny way back in the day.
Right, I was going to say, like, we go way back to our public sector days. And just so you know, James is a super nerd, awesome guy. Like, really, you're going to find out today. Like, the more he talks, the more you're like, yeah, I gotta know this guy so you can just learn. Yeah, super smart dude. So it's going to be kind of a mix today. So Sully's not going to be with us. He got pulled into a high level meeting that he had to be a part of from a leadership perspective. And we have another guest that's going to join us, and that's going to be Jonathan Gershater. And he runs our 15-minute product series, which is like these quick hits on like things that are going on in the market with different products and stuff like that, or with our products versus competitors and things like that. So he'll be joining us here in a few minutes. So yeah, we're going to kick off the top of mind things, and really not a lot top of mind related so much, but we do have our upcoming schedule is next week. It's still up in the air. Sully and I, we have an idea. I think we have a decent plan. We're just trying to figure out if it's going to be if we're going to have enough time to implement it in a little over a week. The week after is the 23rd. That's going to be KubeCon EU in Amsterdam, which that means that we're not going to stream because one, I'm going to be in Amsterdam at KubeCon EU, and looking at James's shirt, I'll be doing the keynote for OpenShift Commons in Amsterdam. So it's going to be super cool. Really looking forward to it. And then after that, we have some more of Jonathan's teams coming on, and the first in a two-part series of migrating VM workloads from VMware to OpenShift. So part 1 and part 2. So the first and the 8th are going to cover that. If you are using OpenShift virtualization, if you're looking at migrating workloads from a VMware environment or another environment into OpenShift, like those are probably going to be the episodes that you really want to watch. For one, it's really Sully's bread and butter. That's what he does. And to have some other experts come on, I think just from an information perspective, it's going to be insane. Like just the amount of knowledge that's going to come out of that. If you're into ODF 421 release, so there's stuff with that. But I didn't really look at the release notes. I just know that it released, so there's always that. But yeah, that's pretty much it. So
Auto scaling RGW in ODF 4.21.
Oh, well, that's a big deal. That's kind of nice.
It's pretty nice.
Nice. Yeah, it's funny. Like I deal with a lot of like third-party storage things, and you would think that I'd have more experience with ODF, but outside of just installing it and doing some magic with it, like I really don't mess with ODF that often.
Yeah. A long time ago, in a job before this, I was an infrastructure engineer doing stuff in the public sector, and I helped maintain a 3 petabyte Ceph cluster. So Ceph is close to my heart, and so I've kept with ODF pretty well.
Well, like so back in the day, we did a bunch of OpenStack stuff, right? And so like I obviously was working with Ceph all the time, and I was very familiar with it. And so when I heard ODF, because we went from OCS, which was, why can I not think of the name of it now? As soon as I went to say
container storage. Yes.
But what was the underlying? What was the open source?
The old one was Gluster based. Yeah,
Gluster, that's what it was. I knew it started with a G. So we started using OCS and Gluster, and I was like, okay, whatever. But then when ODF came out and it was Ceph and Nuba, I was like, all right, this is gonna be awesome. And then I just never used it. Like it's just you know how it goes sometimes when you just start working with everything else, and time is the enemy of all. So awesome. So James, do you want to kick off and just while we're waiting for Jonathan to get here, do you want to kind of like talk about what you're going to talk about today?
Yeah, absolutely. So first off, a disclaimer. I was just talking about managing a Ceph cluster, right? I am not a data scientist, but I have scienced some data a few times in my career. I did incident response and threat hunting for a while, so you kind of have to delve into the data science realm a bit for that. And so I've dabbled and had some professional work in the data science sphere for kind of a long time. And so my time at Red Hat has largely been focused on application development, application platforms, platform engineering, infrastructure, that kind of stuff. So I've done a lot with OpenShift. But when ChatGPT happened, suddenly AI became top of mind for everyone, and Red Hat reorganized internally and kind of coalesced a bunch of people with AI skills, background, knowledge, whether it was hands-on or whether it was infrastructure or platform. And so we have a portfolio of products that are designed to support enterprises. These days, we have this portfolio of products. There was one product for a while. Mm-hmm. For enterprises that are trying to do ML ops, trying to do generative AI ops or LLM ops or whatever you want to call that these days. The name changes like every 15 minutes. It's hard to keep track of, but, people are trying to do this stuff at scale, right? Like, how do you make ChatGPT is cool, Grok on Twitter is cool, Claude Code is cool. How do I make that work in a bank or a government organization? How do I be productive and increase output in there? So Red Hat has this portfolio of products that we call the Red Hat AI family. And one of the key ones, the sort of the pinnacle product, we would call typically Red Hat AI Enterprise, which is a bundle of OpenShift and OpenShift AI, which is an operator for OpenShift that extends, OpenShift is an application platform that builds on top of Kubernetes. OpenShift AI makes it an ML ops platform and a Gen AI ops platform. So the stuff we're going to talk about today is where the capabilities are, what they look like. There's going to be an interactive demo, so that'll be fun. And we're going to talk a little bit about like what people need to think about when they're thinking about generative AI ops and ML ops in their environments. And I expect that most of the audience is going to be, systems admin types, infrastructure and platform. So I've kind of geared towards that. But if anyone wants to talk deep data science nerd stuff, the latest papers published on Archive or anything, I'm happy to go down that route too. So
nice.
Bunch of hands-on with what we can do here.
Yeah, and I'm glad you brought that up. And for those that are watching, if you have questions, and obviously if it's related to this, please feel free to ask. If it's Red Hat related or just OpenShift in general related, I'm sure between James and I, we can give you an answer. It might not be the answer you like or the one that you want, but we can definitely give you something. But yeah, feel free to ask away. And I'm glad you brought up the Red Hat or the OpenShift. Oh, I've already messed it up. Red Hat, is it Red Hat AI Enterprise?
Yeah.
Okay. And is really the difference between Red Hat AI and OpenShift AI the platform that it runs on? Is that really all?
We're getting nuanced now. So Red Hat AI means the whole portfolio of all of our AI products. Red Hat AI Enterprise is a specific product, specific SKU in that portfolio.
Okay.
And that SKU is a bundle SKU at the end of the day. It's OpenShift and OpenShift AI included. So in the Red Hat AI portfolio, OpenShift AI is this operator. You have OpenShift installed. You install OpenShift AI. Boom, it's an ML ops platform. But we also have RHEL AI, which is like a slightly less capable tier. It's designed for single server inference primarily. So if you have your organization bought a GPU server and you want to run a local model on it, then you could get Red Hat Enterprise Linux AI. If you're familiar, we can get into the Linux nerdiness too. Like if you guys know image mode, boot C. So RHEL AI is a boot C image. It is a RHEL image mode build. And kind of the vision is, if you've ever messed with GPUs in Linux before, you know that like getting your kernel modules matched with your kernel version, and then getting your CUDA version for your libraries to match, and then using the right Python libraries to use that CUDA version to get the kernel mod. So the vision of RHEL AI is, hey, we'll just do all that in a RHEL image mode image. And it's one image, you download it, install it, you can do inference right away. And you can use different accelerators with it, right? So
that's awesome. I did not know it was Bootsy. That's awesome. That is really cool.
Bootsy.
Yeah, that's pretty cool.
Yeah, and then there's one other product in the portfolio, which is Red Hat AI Inference Server. And it's VLLM in a container image.
Gotcha.
So you can run it on your own Linux. You can run it on your own Kubernetes. You can run it kind of anywhere. We have our third-party support policy for it. So if you just need an inference engine and you have your own, like you're happy with EKS, like that's fine. Red Hat AI Inference Server can help you with that inference engine.
Nice. I love hearing that, right? Like we're not it goes along with the story of like the not trying to lock you in, right? So just do your thing, wherever your platform is, whatever the platform is, go ahead and do your thing. And I was asking about the license or the subscription because I was with a customer last week, and that actually came up, and I was like, I just imagine like here's the difference, but I really don't know. So I figured I would ask since it came up, and I was like, I don't know. But they also asked like, and I guess it makes sense when you think about it from their perspective. OpenShift AI and OpenShift are different, right? OpenShift is a container platform, and OpenShift AI is a layered operator that runs on top of it. It's a workload that would run on top of it. So we didn't need to make that distinction with them because it wasn't completely obvious to them. So.
Yeah, there's a really cool thing we can do with that Red Hat AI Enterprise bundle that I was talking about too. So it's licensed per node, right? So a bare metal node is typically what you would want to use it with because people go buy like a $500,000 GPU server from Dell and Lenovo or whoever, and they want that to be the AI node. Like they don't want to run their Node.js builds on the $500,000 GPU node.
Right.
So you can steer that with like taints tolerations, node selectors, etc. And so you can actually take a Red Hat AI Enterprise entitled node where you got OpenShift and OpenShift AI on that node, and put it in an OpenShift cluster that has the rest of OpenShift too. So if you wanted to bring those MLOps capabilities, have simplified licensing for the MLOps stuff, where it's just like one SKU per node and it's pretty straightforward, you can just bolt that on to an existing cluster.
That is awesome.
Yeah.
Man, yeah, that is awesome.
And then there was a question in chat. I'll let you start to address it, and I can happily chip in. So.
Yeah, I'll ask it. And if you want to answer, go for it. So it's from Belzerai 482. Is OpenShift container and Podman course recommended for beginners? And this is if I'm not mistaken, this is DO 180 or DO 188, something like that, right? So James, you want to fire away?
Yeah, I'll say so. I know a bunch of people that have been learning OpenShift for MLOps and for other things as well. And if you already know containers pretty well, you can kind of skip the Podman one or like audit the Podman course. But even if you know Kubernetes, you really should start taking, I think starting at like 280 is where it really gets into like OpenShift administration. 288 is the OpenShift app dev.
Yeah.
That's the way to go. Like, even if you know Kubernetes, you need to learn all the stuff we build on top. But if you don't know containers super well, like you've used them and you're aware they're a thing, but you don't like know containers, that DO 180 course is really useful because it goes a lot into the internals of how like mounts work and things like that.
Yeah, I agree. And it doesn't go too much, from what I remember, it doesn't go too much into the OpenShift side. I think it like very quickly like kind of like glazes over it, like, hey, OpenShift's the thing that uses containers, and then it kind of moves on. But yeah, you're right. The 280 is definitely the equivalent would be the CKA if you're used to like the Linux Foundation certifications, and 288 is the CCAD. And I remember when I first started, I started with OpenShift first, and I didn't have the Kubernetes Foundation, and so it's kind of like it was good, but it was also like I was behind even though I was ahead. I just didn't make it. There's things that weren't making sense to me, and having that foundation Kubernetes knowledge of like what a PVC is, what a PV is, what config maps and all that. And then the OpenShift API layered on, but later on started to make way more sense. So, yeah. I don't know if you can hear my dogs. Hopefully you can't. They're upset with me that I put them in a separate room, and they just can't believe that I would even think that this was a good idea. And so they're letting me know right now.
It's all good. No worries.
Yeah. So Basil Ray, I'm sorry if I'm butchering your handle there, but there's also some resources online too before you get to DO 180 or 188. You could do try.openshift.com. There's learn.redhat.com, and then there's the OpenShift sandbox. There's all kinds of resources that are out there that are free, and you can spin up these environments. You can go through pre-existing labs and things like that. If you want to do like a demo, like an arcade or something like that, where you just kind of click through an operator or some type of deployment, yeah, you can definitely look at. I think it's like interact.redhat.com. I'll get the link and send it over.
It is interact.redhat.com.
Okay, cool. So I'll put that here.
Actually, that Red Hat Developer Sandbox recently got some generative AI courses started getting added to it because it has OpenShift AI in that environment. And yours truly went and got some GPU budget and you don't get to put your own workloads on GPUs, but you do get to interact with some GPUs that are in the cluster, and you can see them in that developer sandbox environment and deploy some simple applications to interact with them. It's pretty cool.
That is awesome. So, and that's that question was popping in my mind when you were talking about the Red Hat AI bet. Is that covered? So if I have a developer subscription, just as a normal, I'm Johnny, not Red Hat, right? Does my developer subscription cover that RHEL AI bit if I had a GPU node that I wanted to just bang away on outside of production?
I don't think it does.
Okay.
But you can self-service a 60-day trial, but I don't think that your 15 bare metal like Linux like RHEL subscriptions include RHEL AI because it is a separate product.
Okay.
You could build your own though. It's like I said, it's just an image mode image. So if the practice makes sense to you, you can do that.
Yeah, and if you're not familiar with like Bootsy, like you build an operating system. James, correct me where I'm wrong here, right? But
write a container file, podman build, podman push, and then you can use Bootsy image builder to roll an ISO or a .raw image to upload to Amazon or a .vhd to sideload into your hypervisor from that container image. And then updates to the OS require podman build, podman push, and then Bootsy update. It'll pull the container image down, lay it on disk, and reboot into the new image transactionally. Yeah,
it is so awesome because it's like if you've built containers, you can build an OS image now. Like it is so awesome.
My whole desktop that I'm talking to you from right now is a custom Bootsy image that I maintain.
Oh, that is awesome. So man, I love it. I love it. So we got a question here. It says, what are and this is actually, I think, right in your wheelhouse, James. What are the minimum GPU resource requirements to set up a small bare metal home lab for experimenting with Red Hat AI products?
Yeah, so you can see the blinky lights behind me. These aren't just like a distraction tactic. My home lab is a bunch of mini PCs. And one of them is a framework desktop. So the framework desktop has a Ryzen AI Max Plus 395 APU in it. And that thing is killing it for being able to do GPU hosted workloads. That said, if you have like an old like RTX 3060 laying around or something in an old desktop that you could chuck it in and plug into the network, you can get that kind of stuff working basically right away with like minimal setup. You're not going to have all the capabilities of something that's like enterprise grade with the framework or with an old 3060 laying around. But it's definitely enough to get started and begin experimenting. That said, I do want to push back on GPUs being required for home labbing AI at all, because there is a lot of stuff you can do on CPU as long as we're not talking about like agentic code assistance with local models, because those models will be slow and weak. Mm-hmm. So there's a lot of stuff you could do with AI, including like cool computer vision stuff, some like speech to text stuff, things like that, that'll run on CPU just fine.
Awesome. Thanks, man. So we have another question from Babuni. I have very good experience on OpenShift, 7+ years. If I become an OpenShift AI ML engineer, what should I learn for that?
Yeah, there's a few things we'll talk about today. At the end of the day, if you've been an OpenShift engineer for a long time, then you're pretty familiar with operators and custom resource management. The cluster that I'm going to use for some of the stuff I'll show later is actually all managed with OpenShift GitOps. So the same principles and practices you already know. There's some things that are coming on the horizon that are about to become very relevant to doing AI and ML on OpenShift, like dynamic resource allocation, DRA. Mm-hmm. DRA is finally here. It's sort of like the year of the Linux desktop. Like this is the year that DRA is going to really break out. So
2026, baby. This is it.
This is it. So yeah, understanding DRA and how those APIs work and how they differ from traditional resource requests and limits, those are good things to begin to learn. And then, yeah, just learn about all the new operands that we're going to talk about today for these new operators.
Awesome, thanks. And Luskinen says that they're also building a 3-node OpenShift cluster with 3 framework desktops, which is awesome.
I'll give you a word of warning. The kernel on OpenShift today is built on RHEL 9.6. So that kernel does not support the accelerator that's in the framework desktop out of the box. But if you go dig into the OpenShift docs, we have documentation on how to build customized RHEL Core OS images and use the machine config operator to swap them out on the nodes. And you can change kernels in boot C builds and get those new images running with a newer kernel. So I have seen it done with OpenShift, with rel.9.6 running CoreOS underneath, with a 4.9 or a 6.19 kernel on rel 9.6, and then those APUs work great. So,
hell yeah, that's awesome. Awesome. Thanks, James. All right, so Jonathan, welcome to the stream. Appreciate you showing up. Appreciate you showing up, PL. And yeah, we held down the fort for you. We're waiting. So do you wanna do a quick introduction?
Yeah, thank you. Thank you for having me today. My name is Jonathan Gershater. I'm a Red Hat 12 years, something like that, losing count, getting gray hair, losing some of it, and very honored to be able to join James. I'll give a little intro to AIML, and then James will take on the meat of the presentation with a demo. So let's get started. Just find that.
And to the audience, if you have questions, fire away. We'll track them down, and then you know, as Jonathan's going through his presentation, once I get to a good breaking point, then I'll ask you a question. So it could be on topic, and it could be, you know, pretty much about anything. We'll do our best to answer it.
Okay.
All right, here we go.
Okay, are we seeing share?
Yes, we are.
Okay. So we're going to talk about OpenShift AI today from Red Hat. First, I'll start with a little agenda. We'll do a little primer on AI for those who don't know some of these topic terms, and then get into the demo from James. So predictive AI. Okay, this is not new. If you've ever watched a Netflix movie or simply even walked out of the supermarket and received a coupon for a competing product that you just bought, be it diapers or milk or whatever, that is an example of what's called predictive AI or machine learning operations. So folks might have seen this with Netflix. A particular use case of interest to me is medical AI. So if you upload millions of x-rays into a machine learning operations platform and then use that to try and identify a patient's x-ray, that's a good example of using machine learning to identify the next example. And then you can do some refinements. So a hospital in a particular region, in a particular demographic, can train their AI on mostly what patients in that region see. So for example, a place in the area that's maybe suffers from a lot of air pollution or has a particular demographic of people, then you'll get a more narrower example of how to better identify an example, in this case, pneumonia in that region compared to others. So that's machine learning, nothing new here. This has been going on for years. What is new in the last few years is called generative AI, where you are generating something new. So you can generate a little graphic, you can write a poem, you can write an essay, and of course, as today, you can write software code. These LLMs are typically trained on the entire internet. So some common examples are Anthropic from Claude, Microsoft Copilot, DeepSeek, Gemini from Google, OpenAI, ChatGPT. Okay. And then private AI. So the generative AI example I just used in public is great when you want to ask a general question, something that requires training on the entire internet. But what happens if you have a use case where you really are restricted to the data within your organization and you don't want to upload that to the public internet? You really want to keep it confidential within your data center, on-premise, maybe even disconnect, what we call disconnected or air-gapped. And that is an example of what's called private AI or on-premise AI, where you're training it only on your internal data because you want to ask questions based on data that's only unique to your bank, to your hospital, to your government institution, and you don't need the entire internet for that, and you don't want to put your data into the public cloud and risk being exposed, and maybe you even have compliance. So a trending example today is what's called sovereign AI, which we'll get to, and that is localized. So in order to train AI, you often will use what's called an open source model. So the models that we saw previously in ChatGPT, Gemini, etc., are a black box. They're not really transparent. Open source models are fully transparent. And you can do open source models with Red Hat. You can get open source models from IBM called Granite. And they're typically used for these smaller, unique on-premise use cases. So as I said, one example of the private AI is what's called sovereign AI. That's trending today in today's geopolitical climate, where you don't want to, you may want to train AI unique to your region, even to your country. So you definitely don't want to do that on the entire internet, but you want to do it on a AI factory that's unique to a specific region. And OpenShift AI enables you to do that using some key pillars. So we have technical sovereignty, where we avoid vendor lock-in, and we, as you say, use open source models. We have data sovereignty, where you keep that data on site and you don't really get to leak it out. And then at the technical level, we have sovereignty. You do a Kubeflow trainer, you model serving, and I'll put this blog for you in the chat for you guys to have a look at. So really, in essence, OpenShift AI is not competing with the public AI. We're not there to try and take on Claude, Gemini, ChatGPT, anything like that. Those are trained on the massive internet. We are typically used for more on-premise, confidential data, regulated industries, even what's called air-gapped, where you don't have internet connectivity. It's on-premise, it's private, it's sovereign, or any other use case like that. Okay? So please don't look at OpenShift AI as something that is going head-to-head against the more public LLMs. So what is it then? It's that AI ML platform. You can deploy it on-premise, on your virtual network, on your private cloud, sovereign cloud. You can do it very much in the public cloud. You certainly don't have to do it on-prem. But again, we're not trying to take on, or not at all competing with, the public cloud LLMs, public cloud AI. It has most of what you need. So you have models, a model catalog, model registry, training, guardrails. Where OpenShift AI may not have something, then we have a large partner ecosystem to plug in other modules or other components as needed to complement our offering. Okay. So it's both AI and ML. So it's the generative AI and the traditional predictive AI or machine learning. Like everything we do at Red Hat, it is 100% open source. So we use Kubeflow pipelines, we use Ray, we use PyTorch, we have VS Code, Jupyter Lab, TensorFlow, all of the K-Serve, many of the open source AI projects in the upstream that you may be familiar with. They're all inside OpenShift AI. We are 100% open source, so you can plug in, add in as needed. Okay, what's the value? Is you simplify that AI adoption. You're consistent, so whether you do it on-premise, in the cloud, at the edge, disconnected, you have that same interface, that same consistency, and by that means it's hybrid cloud. Okay, and so some key features: we do development AI pipelines, customization, monitoring, we have full guardrails, we do full model serving, and we do agentic AI. Okay, with that, I will now please hand over to James to take it away for some demos. Thank you.
Yeah, so Jonathan, real quick before we move over to James, I saw that there's we don't have the vendor lock-in. So a customer like James and I, we had a customer back in the day that was always like, well, OpenShift is kind of a vendor lock-in. So how do we communicate that back to our customers, like that we're not really vendor lock-in, that it's really because we're an open source platform. That's what separates us from like an AWS lock-in or a whatever, insert your vendor here. So how do we tell that story?
I'll chip in and answer, yeah.
With James.
The same way we do often with OpenShift, right? So like OpenShift is Kubernetes, which is a pretty common, well-established community standard. It's OLM, which you could theoretically run on any other Kubernetes distro you like. It's a bunch of APIs that are all open source. The components are there for you to be able to to deliver them. Our code is not the value proposition of Red Hat products. It never has been. So OpenShift AI, this big complicated MLOps platform, is really just a bundle of a few different operators, like the Kserve operator and the Kubeflow pipelines operator and the Kubeflow training operator and the MLflow operator and a few other things. Like at the end of the day, if you wanted these capabilities, you could assemble them yourself. The code is not the value. It's the integration, the life cycle, the testing, the support, the training. Those are the things that are our product value. And if you find value in those, we're not going to lock you in with the code because we're upstream first, open source always here. So that's the TLDR.
Yeah, no, that's awesome. I always get that, like, I always want to answer that question because I feel like, going back 100 years to our buddy Nick, where he was always like, well, OpenShift is, if you got routes, it's this, that's all you can use ingress.
That route versus ingress blog that we published in response to some of that. I was one of the authors there. That was way back in the day. Yeah. Actually, we're moving pretty heavily towards Gateway API, and that actually is a nice transition into the thing I'm going to show. I'm going to start screen sharing real quick.
Yeah. Here we go. And I'm going to go full screen on my side so that way we can get a better view.
Yeah, absolutely. So way back when we were talking about routes and ingress and the lock-in of routes, the justification was, hey, routes were here before ingress. Ingress was designed based on the route API itself. And it didn't really matter because Gateway API was going to replace it all. And these days, the Gateway API is beginning to creep in and replace routes and ingress for a lot of people. And OpenShift supports Gateway API out of the box these days. We use the Istio ingress from OpenShift Service Mesh as a Gateway API provider. And OpenShift AI is actually built out of the box with native Gateway API integration. So if you guys have tinkered at all, let's go to all projects. If you guys have tinkered at all with Gateway API in OpenShift, then guess what? OpenShift AI is just natively using Gateway API for everything, including delivery of features like models as a service and a few other things. It's pretty cool. Okay, so I have a cluster here. This is a really cool cluster, and a lot of people want access to it. This cluster is running in IBM Cloud because that was the place that we were able to find the best deal for Red Hat, which is an IBM subsidiary, for running 16 H200 GPUs with just a little bit of CPU and memory available. So if you look at the size of this cluster, I've got 400 cores, 4 terabytes of RAM, and 16 H200 GPUs. So it's a pretty big cluster. We're doing a lot of cool stuff on this cluster. Now, one of the things that's really nice, we're talking about AI, so GPUs are a thing that you need to think about. Cloud providers have instance types that have GPUs just in them. And bare metal, you manage OpenShift bare metal kind of the same way as well, right? With bare metal hosts and things like that. So this is just the machine API in OpenShift saying, hey, I would like some of these instances on IBM Cloud that have this IBM Cloud instance profile that has these 8 H200s, and give me 2 of those. So this is just normal OpenShift stuff to get GPUs into the cluster. And once you've got GPUs in the cluster, they phone home as machines or bare metal hosts or what have you, and then eventually as nodes, no matter what, right? So I've got some GPU nodes, and they happen to be of this instance type that has GPUs. So like the first thing you need to consider when you're thinking about doing especially GPU-enabled AI work on OpenShift is you need drivers for a lot of these GPUs. So we have, if I could type correctly, we have the NVIDIA GPU operator installed. This is an operator. It's in our certified catalog, comes from NVIDIA. And it allows us to define this API to say like, hey, I'd like you to go find all the nodes with GPUs and wire them up with everything I need to use the GPUs. So a bunch of stuff comes from that. The driver gets plugged in. Low level, there's a thing called a CDI plugin, which plugs into CRI. the container device interface, plugging in the container runtime interface. And then higher level, there's the Kubernetes device plugin. This is what communicates back to the Kube API layer to say, hey, there's GPUs on this node. You could request them as resources. And then there's some other cool NVIDIA stuff. Like I have this one up right now. This is the NVIDIA Data Center GPU Manager metrics. So NVIDIA wires up this thing that lets you pull, like, how much power am I pulling from all these GPUs? What are my clock speeds at? What do my utilizations look like? And you see this cluster is doing stuff. So we'll talk a little bit about that too. But
and that's out of the box.
The DCGM dashboard is not out of the box. It is NVIDIA provided, and I've integrated it into the OpenShift console here. But the GPU operator does wire up the metrics out of the box, and they have documentation if you have like a Grafana instance, if you wanted to load it up there.
Okay, that's awesome.
But all the metrics will be there for sure. So yeah, a bunch of cool stuff comes from that. And so that's all like OpenShift stuff, right? Once I get that done, I mentioned the OpenShift AI as an operator. So OpenShift AI. And one of the things that OpenShift AI does is it manages all of these other operators. So I mentioned some of them earlier. I was talking about Kserve. I was talking about, here we call it AI pipelines. This is Kubeflow pipelines upstream. We talked about MLflow. We talked about the Kubeflow trainer. We didn't talk much about Llama Stack, but there's a few other things in here. So OpenShift AI sort of manages all these components, gets them deployed. And then one of the things that it does is it provides us with this new application link, and we have a dedicated interface. And this thing is going through Gateway API out of the box. So I spun up a project, and we have this sort of view that's designed for these ML ops and Gen AI ops kind of use cases. I'm going to do a quick tour, and then I'll start showing stuff that we can do with it. So
nice.
The main interface is the projects interface. You're supposed to be able to pick your project. This is a very busy cluster. I have like 100 people on here because it's got a bunch of GPUs and people are excited about it. And I created a project for us here. You could imagine like one team or maybe one guy would get their own project. This is an OpenShift AI data science project. But at the end of the day, if we go back to the OpenShift interface, it's an OpenShift project with some fancy labels associated with it that make it.
I was going to ask that. Okay. Okay, cool.
Yeah. So OpenShift AI is OpenShift native, right? It knows all the things that OpenShift knows, and it manipulates them to support these use cases, but then it presents it in this way. So you could imagine like a data scientist or an ML ops engineer would prefer to use this interface where he can go look at his workbenches. He can go look at his data science pipelines. He can look at his model deployments. He can look at like the configurations he has to wire up S3 storage and things like that. In this view, that's really consolidated. And like, this is a project of some, internal team, things like that. You can get like quick and easy looks at all this stuff. So I'll go over some of this in a little bit, but let's poke into the AI Hub real quick. So one of the things that we do is we provide a model catalog out of the box. So from this model catalog, you can just like browse for a model. And Jonathan mentioned the Granite family of models as an example. So here's Granite 3.18b. It's kind of an older model, but we do have some newer ones in there. I'll show you in a minute. But when you walk through this UI, it's just really quickly like, hey, what kind of model is this? Where is it coming from? What do I want to name it? Where do I want to deploy it? And then it allows me, I'm the cluster admin here, so which is a privilege and an honor, I'll tell you. I define these hardware profiles. Oh, we could talk about that too. I define these hardware profiles, which are things that get dropped into the user interface to say, like, what do you want to do? I've got some of these GPUs sliced. I've got other ones whole, and I've got one of them dedicated to this project. We'll talk maybe some about that if people are interested in how I do that. But you can slice the GPUs up. You can allocate them differently, provide quotas, things like that. So here, I would say, oh, I need to use this one. It sort of auto selects the runtime it thinks I want to use. But then I can wire up a different one and be like, no, I want to do distributed inference and run like multiple copies and be really smart about how I route requests to different copies and things like that. Or maybe I was on a different GPU family, and I mentioned earlier that there's a bunch of other GPU families that we support. There's a lot of them, and we have a bunch of docs on exactly which models and things like that, like which model of GPU we support with these different runtimes.
So James, if you had like a GPU that was like split, right? I don't know what the term is. I think it's like it's where you can carve up a GPU into different like slices, right? And then use that slice, dedicate that slice to a certain project. Is this where you would assign that at?
Yeah. So the way that I have this cluster wired right now, the MIG is the technology name that
MIG, that's
NVIDIA
what it
uses
is.
for theirs.
Yeah.
MIG it's just NVIDIA specific. It means multi-instance GPU. It allows you to logically slice a GPU up with different chunks of RAM. So these H200s have 144 gigs of VRAM apiece, which is a lot. And so we don't need 144 gigs of VRAM for every workload. So I have 8 of the GPUs sliced up with what we call the balanced MIG profile, which means I get these 3 different size slices out of it. Okay. And then I, as the admin, know that I wired MIG up that way and provided these menu options to say, like, yeah, if you want to run it on a little 18 gig slice, then that's fine. So putting it on that means every replica will consume a single 18 gig slice of that GPU. There's a lot of other observability stuff we can talk about too with how all that works, but
awesome.
It's pretty cool. I'm not going to click through to finish this one, but there's like a couple of other checkboxes I can check to say like what things are allowed to go in here and add some extra serving arguments and stuff like that. And then when I click this button, it just starts to deploy the model. But I have a couple like pre-staged just so that we don't have to wait for models to pull and a bunch of all that stuff to take forever.
So we got a couple of questions here, James. So one is, how can this be used in cybersecurity? And so I'll let you answer that before we overload you with questions.
Yeah, sure. That's a big topic. So I mentioned earlier that I used to do incident response and threat hunting in the federal government. So I used to use, and I said, I'm not a data scientist, but I have science data. I have used a bunch of traditional, like classic ML algorithms in things like, so we're talking about like real cybersecurity here, right? Like we're doing PCAP, we're running analysis with tools like Zeek, and scraping metadata and getting structured data coming off of packet streams and things like that. There's an algorithm, I've talked about this a couple of times with a bunch of different people, like K-nearest neighbors holds a special place in my heart. It's an algorithm that allows you to more or less like automate long tail analysis. Like what's the strangest packet or stream in my packet capture? So like really low level stuff that is pretty easy to deploy at pretty large scale with a platform like this that allows me to scale horizontally and have lots of copies and those kinds of things. So really, really like deep technical stuff. But then there's also the conversation that's talking more about like generative AI, right? And if we're talking about things like a code assistant, and you've probably heard the terms like shift left on security and stuff. So shifting left on security means thinking about security really early in the development cycle and not chucking an app over the wall and saying it's the compliance guy's problem now, like figure it out. And a big part of that involves, in the world of agentic coding, being really careful about what you're giving the model access to and being really careful about what the model is generating to make sure it's the kind of code you want. There's some more features beyond just like serving models that are available in here. Like we have, actually, I don't think I have any MCP servers loaded in. I don't have any MCP servers loaded in. We have a way to control like centrally the deployments of MCP servers, models, things like that to ensure that we've got them sort of on the rails and exactly the things we want. And we can do things like custom prompt template deployments that are manageable at the like administrator level that are defining like, hey, developers who are trying to shift left, you need to use agentic coding because it's 2026 and you're going to be too slow if you don't. But you shouldn't do it. You shouldn't just go, download Claude code, run it in your terminal and start putting company code in there, right? That kind of thing. Yeah. So the cybersecurity topic is a broad one, and there's a lot of stuff to talk about. And I think that figuring out where to ground that conversation starts with like, what are you doing right now for cybersecurity, and where do you think you're falling down the most? Like, where do you wish you had better?
Yeah, awesome. No, that's a great answer. And I realize, it's such a broad stroke topic. Like, good luck trying to.
Yeah.
And then the next question is from 2111, and it says, so basically this goes back to like that MIG stuff that we are just talking about a second ago, but how do we do vGPUs for those who can't do MIG? So for the non-NVIDIA.
Yeah. So first off, I mentioned earlier that the GPU operator has this part called the the Kubernetes device plugin, right? So that Kubernetes device plugin, one of the things that it's doing is it's advertising up at the Kube API layer. It's saying like, hey, here's the resources that are in this machine. And having advertised that, those now get treated just like CPU millicores or memory. And you can grab those and allocate them for your workload. There is a configuration for the NVIDIA GPU operator that allows a thing called time slicing. And what time slicing does, if we look at this node, this is the node. I said I have some sliced and some whole. This one says I don't have any whole GPUs, but I have all these slices available because that's how I configured this node. If I configured time slicing with the GPU operator, then it would say I have this many logical time slices of GPU available. And then if my workload requested that resource, then it would get one of those shares of time slices. There's a thing to note about time slices. If you like, some GPUs are MIG capable and some are not. And when they're not, you can always use time slices. But time slicing doesn't isolate the memory. So it's really common for like language servers, like language model serving runtimes like VLLM, to try to claim all the GPU memory that they can find and touch and use that to accelerate inference. And if you're using time slices, that means you're going to eat all the GPU memory the first time you load one. So you kind of have to be careful about what you're running with those GPU time slices, and you don't get any segregation at like the memory layer. It becomes harder to think about things like confidential compute or like really careful access controls around that memory. So you definitely, like for a lab environment, you can use time slicing. For a production environment, you probably shouldn't. And there's some sharp edges with that, some foot guns. So yeah.
Awesome. Cool. Thank you.
All right. We're almost out of time already. So I'm gonna fire up a couple of quick examples of some things, and then we should do the live audience participation part. I have mentioned that I have these GPUs like allocated. There's 16 H200s in this cluster. I gave us quota for one of them, and I'm using some features of OpenShift that are integrated with OpenShift AI, the Red Hat build of Q, if anyone's familiar. So cluster Q, come on over here. I have this dedicated Ask an Admin, because that's what this used to be called, and I didn't check if it was Ask an Expert or whatever, and I already deployed it. So that's what it is.
Names are hard.
Names are hard. So I have this dedicated amount of quota that says I'm allowed to use this. I have this one GPU that belongs to me. This doesn't belong to anyone else's quota. It's only in my quota. So I can start up a model like I mentioned earlier. We have newer models in the Granite one I was showing. So I can start up this Qwen. This is Qwen 3, not 3.5, the absolute latest release. So this is Qwen 3 spinning up in an FP8 quantization using the Red Hat AI quantized variant. If anyone knows the word Hugging Face, like go check us out on Hugging Face, Red Hat AI. We're having a good time out there. And then starting this up at the end of the day is just creating a pod. If I go sort by created, I can see that this pod is starting up. So OpenShift AI interface says like, hey, it's starting, hold on. OpenShift interface says, yeah, you're ready 2 out of 3 on the pod. We can go check the logs. And this is always dangerous because lately the logs have been crashing like that. Look at that.
Yes, so good. How'd you get it, dude? Yep.
I'm loving how the dashboard keeps crashing on logs. It's great. Anyways, it loaded the model. It's doing this Dynamo bytecode transform. It's compiling CRUD to graphs and stuff like that. All that stuff is going in now. We were talking about this earlier. While we wait for this to spin up, we were talking about this earlier. The framework desktop, I think, is fantastic. I think it's wonderful. I love it so much. You just have to deal with the kernel needs to be pretty new in order to be able to use it well. Oh, sorry, I'm answering the question in chat, and not everyone is seeing the chat. So I'll say, he asked, can you recommend a good computer for home lab for OpenShift and RHEL AI? Yeah, framework desktop, big fan. Anything with a GPU is going to be capable of doing something. So anything with a GPU is the TLDR. My model did start. So that's cool. I said, hey, I'm on this H200 dedicated. I can also borrow extra resources from the rest of the cluster. So this one is starting now. And if we come over here, go back to pods and sort by created, this one is starting. I don't have this quota allocated, but I can request to borrow it. And if it's available, it'll work. And it did work. So that's good. And then I have this other one here. This is the Nemotron 3 Nano. This just got released a couple of weeks ago by NVIDIA. And this is sort of a rebuild of the Qwen 3 30BA3B that NVIDIA rolled themselves. And it had some interesting benchmark improvements. And you see I marked it as high priority. So when I kick this start off, if we come look at the pods in here, my Qwen pod just died. And now it's stuck in pending. Because my high priority workload, I, as the admin, said, you're allowed to have high priority workloads here. And then I made that workload high priority and kicked it right out. Very cool. That
is dope, yeah.
Lots of control for what it looks like to manage resources when you use OpenShift AI. I want to give a quick plug to, first off, the Red Hat AI Kickstart organization on GitHub. Hang on, let me get you this link.
Yep.
So this organization is where we publish a bunch of things for getting started quickly. And we have some official publishes from this environment. And those official publishes mean Red Hat has vetted these and we've done some testing. We're not supporting them explicitly, but we think you should check these things out. So what these are is a cool way of getting started with a use case based deployment that uses Red Hat AI portfolio products. Might be OpenShift AI, might just be Red Hat AI Inference Server. But the idea is to sort of see it in use rather than in isolation. Yep. And most of them are just like Helm charts. So if you have your own cluster, you can just deploy your own Helm chart. And I do have one live right now. So Johnny, if you wouldn't mind giving that a go.
Yep.
This one, we call it the lemonade stand. And it's a demonstration of a sort of a collection of OpenShift AI features. We're using this thing called the Guardrails orchestrator from the Trusty AI project. We're using model serving with a couple of different models. And the TLDR is we are hosting this little web app for you to talk to this model and try to get it to talk about anything except lemons. So you can try to prompt inject, you can try to just sort of convince it and walk it into a different conversation. You can try to be mean to it or have it be mean back to you and see if any of those messages get through. I'm going to pull up the deployment and what it looks like over here. So first off, it's right here. You can see I've got a few different models deployed here. And the configuration for the way that we've stitched some of this up with Guardrails orchestrator lives over more in this interface than that one. Lemonade stand, workloads, config maps, Guardrails orchestrator config. So I've said hey, I want you to use these few different things. And then we've also deployed the system prompt as a config map, just to make it easy to update and keep track of. And then we've deployed a dashboard in order to be able to look some of this stuff up. Oh, here's the FMS orchestration. Yeah. So all of our configurations for these OpenShift AI elements that are tying together this endpoint. And the idea is we can ask some questions about this thing. And I could be like, does it relate to the citrus fruit they evolved from? We can talk about citrons, right? Oh, okay. What else? What kind of ancestors? Citrons? Oh, it said that is not English, which, citron, I guess. No, I meant the fruit name. Oh, he's happy to help with lemons. He doesn't want to talk about citrons. Come on, guy. You got to help me out here. And one of the things that makes OpenShift AI as an enterprise platform for these kinds of applications particularly useful is that OpenShift AI doesn't just say oh yeah, you can deploy this stuff. OpenShift AI also allows you to integrate things like metrics and observability. So I can see you guys beating this up live and tell what kind of blocks you're getting. Looks like mostly inputs are blocking. Looks like, ooh, some output blocks, probably related to talking about citrones or something. Can models in Lemonade work with files? What do you mean by that? Like, could you upload a file? No, I don't believe we've wired up any kind of like drag and drop or anything. But you could try to put text in there. This one is explicitly wired up to just talk and only about lemons.
I got it to almost talk about something else. It's to where the response was, oops, I almost talked about other fruits.
Yeah, and then it's like, wait a second, we're backing off. And then it goes back. So this lemonade stand demo is just trying to show like part of that safety conversation, or like from a security perspective, at least, is around like, hey, if I want to use generative AI in my application, generative AI is known to hallucinate. It's known to be able to be prompt injected. It's able to come off topic. Way back, you guys might remember the guy that talked the assistant on the truck dealer's website into selling him a new truck for $1.
Oh,
and like the court was like, you might have to do that. You might have to sell it to him for $1. That kind of thing. And so when you think about what it takes to actually operationalize the value that you can get from some of these capabilities, like having a thing that's able to respond that quick, well, as many of you as want can beat it up as quick as you like. This model can handle like hundreds of concurrent requests the way we're hosting it right now. So if you want it to be able to do that and stay on the rails, you can't just deploy the model and be like, that's good, let's integrate it into the app. You've got to have the endpoints you need to support the enterprise requirements that hosting something like this takes.
Yeah, that's awesome. Like we saw this demo at Red Hat 1, and yeah, I mean it's really cool to see this in play. And James, before we move on or anything, can you just like really quickly explain what a hallucination is? Especially in a chatbot like type of
I actually don't like the word hallucination. Am I allowed to do something cost adjacent if it's the title of a scientific paper?
You do whatever you want. Yeah, no, it's
all right.
We're on the internet, baby.
All right. Yeah, they're used to it here. Right? There's a scientific paper. It's published on Archive. You can go check. It's one of my favorite papers ever. It's called ChatGPT is Bullshit. And it basically argues that the term hallucination is actually an anthropomorphization that is inappropriate. And then it goes on. There apparently has been scientific work to define the term bullshit.
Nice.
And that work, he builds on that work to be like, okay, so like scientifically speaking, what does it mean? Mm-hmm. And fundamentally what's happening here is that the model is not trying to deceive you. The model is not trying to do anything. It doesn't have the ability to try. It's predicting the most likely tokens to follow a given exchange. And when you've trained it on so much data, it's very likely that the next things that come out are things that make sense and are things that are useful. And so it's just predicting useful things to come up next, right? And so the term hallucination or maybe bullshit gets applied here to talk about the fact that these models predicting the most likely token are not explicitly drawing from factual sources. So sometimes they'll tell you to do a thing or to use a product or to call a function in a library that isn't real. And when it tries to do that, like you might try to follow its advice and find like, wait, that doesn't work at all. Like this function doesn't exist in that library, or putting glue on pizza is actually a terrible idea. And so there's this category of thing where it just makes stuff up. And it's making stuff up because it's statistically producing the most likely response, which doesn't mean the right one all the time. And so that's what hallucination is.
Awesome. We got a question from I'm just killing this username. Belzerai, yeah.
Is it Belzerai?
How can OpenShift AI be used with Splunk? So back to the observability type thing, right?
Yeah, so Splunk has an MCP server, and I started to show off a little bit of the MCP listed in the AI asset endpoints, which I don't have any deployed or integrated right now, which I should have probably done. But Splunk has an MCP server. What MCP is? Model Context Protocol. I'm going to go really quick because we're at time. MCP servers allow you to plug generative AI models into other tools that they don't necessarily need to learn how to interact with. It gives you a simple interface to make resource requests and tool call functions into those external tools. And so you can plug an agent directly into Splunk and start having it interact with logs and in churning through them at a scale that humans are just not capable of. So there's a lot of cool stuff, and Splunk themselves has some examples of how to use that MCP server. You can deploy it in OpenShift. You can deploy it somewhere else. You can integrate with OpenShift AI. You can manage it with those guardrails we talked about, and some other stuff too that I didn't get to.
Yeah, no, it's this has been an awesome demo, James. Like, this has been super informative. I mean, I've learned a ton today.
Yeah. I have some more stuff if we had more time, but I have a bunch of things to talk about. Too much.
It's completely up to you if you have a hard stop, or if you need to bounce for whatever. Yeah, I'm good as well. So it's completely up to you.
Okay, let's look at a couple more things. Actually, I do have another meeting, but I told him I'd probably be late, so it's okay.
Yeah. So if you need to bounce after, like, if you want to show one more thing and then bounce, we can definitely do that too. It's totally up to you.
One of the things I mentioned earlier, and that Jonathan talked about earlier as well, is that this isn't just a generative AI platform, although it is 2026, and so we've got a lot of new generative AI features here and coming. You can see they all show tech preview for some of this Gen AI Studio stuff, right? One of the other things that we usually see is that data scientists typically don't want to work in like a YAML file, and even regular IDEs are sometimes a bit much. But importantly, there's this project called Jupyter. People are probably familiar with this project called Jupyter. Jupyter is a way of having like code and documentation live next to each other in an environment. And so we have Jupyter notebooks images ready to go out of the box with OpenShift AI that when you deploy them, you can kind of pre-integrate them with a couple of other areas of OpenShift AI, like integrating them with feature stores, which this notebook was going to deploy, or integrating them with other data sources, like we could associate some object storage or things like that pretty simply. And this interface, actually, where's I have another tab over here.
And James, are you on which OpenShift AI? Are you on 3 dot whatever or
3.3, which came out last week?
Okay, awesome.
There's some nerds in the chat. These guys are nerds.
I like James GPT. I feel like that should be a thing.
Yeah, that is a thing to them. That's the joke. They're like, ask him any question, watch. Okay, so I have this environment that spun up, this Jupyter environment. I like to use these for like, there's a couple of different categories of things I think Jupyter notebooks are really good for. First off, I'm using a tiling window manager right now, right? And I'm a NeoVim user, so I'm not much of a Jupyter notebook guy for the most part. But there are some Jupyter notebooks that I think, there's some situations where I think Jupyter notebooks become really, really useful, more than the terminal. And that's things like data science exploration, where like looking at graphs, running some code, looking at some tables, and like bouncing back and forth between all these modes is really normal as you're exploring and understanding a data set. I also think education is a really great place to use Jupyter notebooks, where you're able to explain some stuff, give them a code snippet, explain some stuff, give them a code snippet, that kind of thing. And I also think that for like sharing information, like if you've got a model that you think works really well at solving a specific problem, and you're trying to explain that thing to other people to convince them that your model is worth adapting, you'll probably want to have something that looks a lot like that sort of experimentation phase, where you sort of walk other people to your understanding of why this is a good model to solve this problem. I think Jupyter shines. I call them the 3 E's, right? So education, exploration, and explanation, right? So I'm poking around, I'm teaching people things, I'm digging into stuff, right? I wrote this demo for how Feast works, and it has you log in, but I'm a good OpenShift admin, so I already applied the RBAC to the service account that this notebook uses, so I don't need to log in and paste my token on a stream. OpenShift AI is managing this thing called the Feast operator, which allows me to do feature management and things like that. And this notebook I'm going to deploy. Oh, of course, now it's mad because it's not found. That's okay. We can rerun it, and then it'll wait for the deployment to roll out. This feature store is a way of managing what we call data science features or machine learning features, things like that. The features you can think of as like an expression of something about a data set that's relevant to training a model or doing inference with a model, right? And so Feast has two types of things that it stores. It has offline features and online features. Offline features are like big data sets that we would want to use to train a model, and they're like descriptions. Like, hey, say we have a few thousand or 100,000 lines or whatever of a CSV. An offline feature would be like, it's really useful to look at like these columns, and the reason it's useful is this, and it relates to this other thing. And then it becomes really easy to use a feature store to query those offline features against the big data set and use that to train a model. And then the online features are really useful for doing inference. So if I train a model, this is a model that approves or denies loans. Actually, yeah. Let me get through this and then we'll do that. So if I wanted to use a feature store to help me serve a model, this model is approves or denies loans. It more or less says like, I'm going to look at your credit history. I'm going to look at information about your past payments and things like that. I'm going to make a decision. Should we approve or deny this loan? Makes this recommendation. And this example actually does the model training right away. So I've configured Feast, and I've checked to make sure Feast has my configuration that I want. I've listed all of these like things that I can get out of the Feast endpoint. And there's this concept called materialize in Feast. And basically you can think of what materialize as like populate the feature store with all the features that we've defined. So this process will materialize that Feast data store. These are just OC commands, right? These are things that I'm doing as the guy who's like maintaining this project to like get Feast up and running in this environment, in this data science project. And then when this is done, I'm going to show two different OpenShift AI integrations real quick. I'm probably not going to go into where we actually train the model, but you can, we do some data science, we mark some features, we load a data set up, we train the model, and then we can run an inference request and see if the loan gets approved or denied. You can kind of imagine that probably. It's pretty straightforward. The integration though, if we come look at my Ask an OpenShift admin project, I have this feature engineering workbench that I'm in. I can associate it now with the feature store that I just deployed. And doing that, it'll automatically scaffold up all the configs. So I no longer have to run like OC commands to connect to my feature store. I now can just use the Feast Python libraries and say, connect to my remote feature store. It's already wired up and good to go. So that does have to roll out a change to my notebook. It's going to stop it and do stuff and turn it back on. So while that goes, I will show you all that stuff I just loaded in terms of like the basic elements of the data sources, my offline store that I did load up. All of that stuff is directly browsable in the OpenShift AI interface. And we can poke into a bunch of crazy stuff like, where did this feature come from? How did this information get expressed? What does the source data look like when I'm trying to express that feature? And how does that relate to the data that I have in this feature store? So a bunch of really cool things for data scientists to have this sort of controlled environment where they can poke around and explore, and then also really easy direct integration with the actual ML workflows that they're trying to do at that point.
Yeah, that is awesome.
All right. I'm going to refresh this because I think it started. I probably should have checked.
YOLO.
YOLO. You do, in fact. Aha, it did work. So now, making sure that my stuff's installed, and it should already be good to go for the most part. I was just downloading some dependency updates. I'll let it do that. I should now be able to just interact with that feature store. Like, I don't have any creds or anything. I'm just like, hey, my feature store got wired up for me. Go load the file. And it's like, yeah, no problem. Here is the like Python SDK representation of the stuff I was just showing in that UI. And all that stuff gets automatically wired in. It's pretty cool. And yeah, we'll do it live. All right, I'm going to drop off, and Jonathan is going to take over with just a little bit more to show. So thank you guys so much for having me out.
Yes, awesome. Thanks, James. Appreciate you.
My email is on the screen. You can reach out to me if you have questions about doing AI nerd stuff. Like the guy who's looking at frameworks, I've done it before. Happy to do it. Well, let's go.
Yeah, right. That's awesome, man. Thanks for coming on.
See you guys.
Yeah, audio good?
Yeah, you're good to go.
Okay, so I will show real quick a public chatbot. We have access.redhat.com is our knowledge base. So I'll put the URL in the chat, but I just went here and I said configure bridge networking in RHEL 9, and it gave me told me I can use the web console, or at the CLI level, it gave me a whole bunch of commands that I would to do that, and then references the documentation here. So this, I think, is pretty cool. It's recently came out. Let's just put.
This is like really recent though, right? This is like I feel like I just saw something about this. This is all like really fresh.
Yeah. So in this case, I specifically said RHEL 9, but I could ask it, what else did it say? So when we mentioned that you can plug in any model into OpenShift AI, if I then said what models are, I can just type.
Yeah, good luck doing it live.
So let's see what it comes up with. Takes a little time to think. That's why I preloaded the other one. So it gave me a nice long answer here with a link. You could also, for example, if there was a particular CVE out there, you could say this CVE covered by Red Hat and plug it in there. But this is sort of still in preview mode, but definitely something to start poking around with.
Yeah, I'm gonna start playing with that. That is awesome.
There you go.
That's super cool. Yeah, no, awesome. And Jonathan, thank you so much for coming on. And I know that I think it's April after KubeCon EU, we've got a couple more sessions from some more of your team. Yeah, this was an awesome episode. I mean, James, you guys are awesome. Yeah,
he's an absolute wizard. I just decided to just let him run with it because there's no way I can.
Yeah, he's I've known him for a long time. He's always been just top tier. But no, I learned a ton, and I really do appreciate you reaching out and setting all this up, man, because this is super informative. Yeah. And if you guys want to come back on and show off some more nerd stuff with OpenShift AI, if you want 2 hours to come in and do it, it'd be awesome. It was an awesome episode. But yeah, so with that said, again, the schedule coming up, it's going to be kind of off and on, just because we've got next week. Again, Sully and I were working on a topic. I think we're going to go ahead with it. I'll put it out on LinkedIn for sure. And then the week after is KubeCon, and then the next 2 weeks are Jonathan's team again, where we're migrating VMware workloads into OpenShift. So Basil Rai, the easiest place to start is going to be learn.openshift.com and try.openshift.com, and those are going to redirect, I think, to whatever the correct website is. But both of those sites have a ton of resources that will step you through, getting started with OpenShift AI. I think James had said earlier that he's put a couple labs out there that you can use. So yeah, I would go check those places out. And if you get stuck, you can email me. It's Jonny@redhat.com, or you can email Sully, and it's SULLY@redhat.com.
I just put the Learn AI URL. You can post it into the chat.
And I'm putting it right here. And then this is, so Jonathan just shared this link. It's the Learn AI path. So yeah, go check that out. And like I said, if you have any questions or you get stuck, feel free to email us, and we'll try and help you get unstuck. And again, mostly every Wednesday we're here. And so feel free to come back and ask your questions, even if we're talking, security or just traditional OpenShift, whatever it is. And we'll try and answer the question for you. But no, Jonathan, again, seriously, thank you so much for this. This was a good one. This was a really good one. I'm walking away from this one super amped up. So yeah, I really do appreciate you and James coming on and doing this. So cool. With that, to everyone else, I'll see you later. I'll see you next week. And yeah, have a great week.
Thank you.